Hello, my dear students. Welcome back. I know your exams are just around the corner, and so many of you have been asking about Chapter 5. Now, don't you worry one bit. Euclid's Geometry is a super important chapter, but I promise you it's also one of the easiest. Let's make sure you get full marks on this one.
Okay, so to get started, just imagine this. Imagine trying to cook a delicious biryani without any recipe. One person thinks you should add salt, another one is adding sugar. It would be a complete disaster, right? Well, for a very, very long time, geometry was exactly like that, just a big jumble of ideas. That is, until a master chef named Euclid came along and created the perfect recipe book for all of mathematics. You see, for thousands of years, people were using geometry for all sorts of amazing things. From building massive pyramids to planning entire cities. But there was a huge problem. Nobody had actually written down the universal rules. The one single recipe that would work for everyone, everywhere. Just take a look at this. Way back in ancient Egypt, they were using geometry to redraw the fields every time the Nile River flooded. And right here, in our own Indus Valley civilization, cities like Harappa were perfectly planned. They had parallel roads and bricks made in a fixed 4:1 ratio. In ancient India, the Shilpa Sutras gave clear rules for building Vedic altars. Then, the Greeks came along and started asking that one super important question. Why? They wanted proof for everything. So you see, everyone was using geometry, but it was all, well, disconnected. And this, my dear students, is where our hero, Euclid, enters the story. He was a teacher in Alexandria in Egypt, and he looked at all this chaos, and he decided, okay, I'm going to collect every single piece of geometry that we know and organize it once and for all. So, what did he do? He wrote a book called Elements. And listen, beta, this was not just any book. It became the single most important mathematics textbook for over 2,000 years. Can you believe that? Every student everywhere on Earth learned geometry from Euclid's Elements. It was like the original NCERT textbook. Now just look at the incredible change he brought about. On the left, you can see the chaos before Euclid, just a mix of rules with zero proof. And on the right, you see the result, a beautiful, logical system where every single idea is proven step by step, all starting from just a few simple truths. He literally created order from chaos. So how did he do it? Well, he started with two basic tools. The first tool is called Axioms. Now, I want you to think of axioms as just pure common sense. These are rules that are so obviously true for everything in the universe, not just for maths, that they don't need any proof at all. Now, don't get scared by the formal definition here. An axiom is simply a statement that is a universal truth. It's something you already know in your heart is true. We're just giving it a fancy name. That's it. Okay, let's look at the first three. Axiom 1. If Ram's height is equal to Sham's height, and Sham's height is equal to Mohan's height, then obviously Ram and Mohan have the same height. Simple. Axiom 2, if you and your friend each have 100 rupees and you both get another 10 rupees, you'll still have equal amounts, right? And Axiom 3 is just the opposite. If you both spend 10 rupees, the money you have left is also equal. See? It's just common sense. And the next two are just as simple. Axiom 4 just means if two things fit perfectly on top of each other, well then they're equal. And my favorite one, Axiom 5. The whole is greater than the part. A whole pizza is always, always bigger than one slice. Bilkul obvious, right? It's a universal truth. Okay, so that was his first tool. Now for his second tool, postulates. So if axioms are the common sense rules for everything, postulates are the special starting rules made only for geometry. Think of them as the basic game rules for drawing lines, points, and circles. The first four postulates are super straightforward. 1, you can connect any two dots with a straight line. 2, you can make any line segment as long as you want. 3, you can draw any circle you can possibly imagine. And 4, a 90-degree angle is always a 90-degree angle. Easy peasy. But that fifth one, that one is special. Let's take a look. Now, I know postulate 5 looks a little complicated, but trust me, it's very simple. Imagine you have two lines, and a third line cuts across them. Just look at the inside angles on one side, like angle 1 and angle 2 that you see here. If you add them up and their total is less than 180 degrees, then I guarantee you those two lines are going to meet on that side. That's all it is. It's just a test to check if lines are parallel or not. Okay, theory is done. Now for the best part. Let's see how we can use these simple rules to solve actual exam questions and score full marks. Are you ready? Let's go. All right, first question. Read it very carefully. A terminated line can be produced indefinitely on both the sides. What do you think? Is this true or is this false? Think for a moment. Which rule does this sound like? An axiom or a postulate? And the answer is true! Shabash! If you got that right, well done. You're already starting to think like a master of geometry. But the important thing is, why is it true? Let's look at the reason. The reason it's true is because this is exactly what Postulate 2 says. The only trick in this question is the old language. What Euclid used to call a terminated line is simply what we today call a line segment. See? Easy marks! All right, next question. Let's keep the energy high. True or false? Only one line can pass through a single point. What do you think, Beta? Is it true or is it false? The answer is false. Fantastic! If you got that, give yourself a pat on the back, because that means you're really paying attention to the small details. Let's see exactly why it's false. And this diagram shows you exactly why. Look, through one single point, you can draw infinite lines, as many as you want. It's just like the spokes of a bicycle wheel all meeting at the center. You always need 2 points to lock in one single unique line. That's the rule. So, we've learned the rules, we've solved some questions. But what is the big takeaway here? Why is this Euclid so important that we're still studying him thousands of years later? The answer is this. Euclid gave us a new way of thinking. He taught us how to take a few simple, obviously true ideas, the axioms and postulates, and use them step by step to prove very big and complex ideas. This method of starting small to prove big things, it's the foundation of everything from rocket science to the code that runs your favorite video game. It's that powerful. So please remember this, my students. The best thing Euclid gave us wasn't a formula for a triangle, but a powerful way to think. Always start with what you know for sure is true, and build your argument from there, step by step. If you can do that, you can solve any problem, not just in maths, but in life. And that's it for Euclid's geometry. I really hope this explainer made it super simple for you. If it did, please hit that like button, share it with your friends, and subscribe for more explainers just like this. And let me know in the comments which chapter you want me to break down next. Study hard and all the very best for your exams. You are all going to be brilliant.